Hi there and welcome to this video for Senior Physics on Electromagnetism and Electricity. In this video we're going to look at AC rectification. What this is going to do is conclude a lot of the work that we've done on diodes and capacitors to actually convert AC into DC. Alright, so what is AC rectification? Well, basically this is useful in the process of converting that AC or alternating current into our DC or direct current. Now it uses the effect of a diode. Now in diagram 1 here you can see that we've got a diode placed in an AC circuit flowing through a resistor. Now DC is continuous, so we want it to go in one complete direction, but unfortunately AC is continually changing its terminals, going from positive to negative and back again. And in the West this happens 50 times per second, and we call that 50 Hertz. So we get 50 waves, 50 changes per second as the electricity is generated from the power station. So if we place a single diode into a circuit which has got AC supply similar to the diagram we get at 1, what we get is a curve which is generated as in diagram 3. Now in that curve you can see that we've got two positive peaks, then we've got a flat line where the negative peak is. Now this is because the diode has prevented the electricity going in the alternate direction. Remember, a diode is like a gating system. It will only allow you to flow through in one way. So what we've done is managed to cut off that bottom portion of the AC supply. Now what we need to understand that the diode will only work if we've got 0.7 or higher volts of energy. So as a result, what we get is a line which is just above the top, and our voltage out at this point will be Vn minus 0.7 volts. Now that 0.7 can in most cases be quite minuscule, and as a result we don't even look at it. But it does help us understand a little bit if we were to link back to our VRMS with the idea that the DC voltage is always going to be a wee bit lower. Now that's because you're going to be losing some of that energy to get across that diode. And obviously if you can't remember what that's about, go back and check our video on diodes, and that will explain that 0.7 joules of energy per coulomb is necessary to actually jump that depletion zone of the diode. Anyway, back to our AC rectification. This process of this one single diode chopping off that bottom portion is called half rectification. Why? Well, we basically got rid of half the wave of our AC supply. So basically what this means is we've now got a gap in our current. We've got two peaks and we've got a flat line. So what we need to do is use more than one diode in order to produce the current to flow in the same direction from AC. So we use something called a bridge rectifying system, which is a 4 diodes working together. Now what you've got here on this diagram 1 is you can see your bridge rectifying diode system there, often called a Wheatstone bridge. You've got your 4 diodes, and then you've got your voltage in. This is coming from a transformer, and then that's passed across a resistor, and then obviously you get your voltage output. Now the key thing to understand is that when we use our Vn is going to be continually changing, which means top and bottom will be positive and then negative, and then it will be negative and then positive. So you get the idea that it's continually changing, and that flow of current and this setup of diodes is going to allow all of the electricity flowing through RL to be in that same direction. So what we want to do is to make sure we've got multiple peaks as we've got in diagram 2. So how does this happen? Well, what happens is we're going to be constantly changing direction. So 2 and 4, basically if the top of the Vn is going to be negative, then the negative electrons will flow through that number 2, flow down through RL, come back up and go in through the diode number 4, and then go back to our Vn. Then when it swaps, so it going in the opposite direction, we get 3 basically having electricity flowing through it, goes through RL, drops up to number 1, and the result is it goes back to our supply. And as diodes work in pairs, the result is we'll have a drop in energy of 1.4 volts, basically because of the 0.7 per diode, and we've got 2 diodes which are used there, so we're going to get a drop of 1.4 volts. So we've got an example of a bridge rectifier as a component, which you can see here. Alright, so what happens now? Well, we've now produced a curve which looks similar to the diagram we've got here, where we've got lots and lots of peaks. Well, those lots and lots of peaks are great, but you'll notice that the voltage is continually dropping down to 0 and then up to a maximum, then down to 0, then up to a maximum. They're all on the same side of the curve, which is great, but it's like turning and switching the lights on and off and on and off and on and off. It's not good for the circuit. So somehow we've got to actually produce a flat line curve, a horizontal flat line curve, where we fill in those gaps between each of those positives. And that will come down to capacitor smoothing, which I'll introduce in the next video. Okay, well, I hope that makes sense, and I hope to look forward to seeing you join me again. Thanks for watching.